comprehensive summary on Rocket Lab, past, present, and future. Overview. Rocket Lab has emerged as a significant player in the aerospace industry, focusing on launch and spacecraft technologies since its founding in 2006. This report explores the historical context, current operations, and future prospects of Rocket Lab, drawing insights from various credible sources. 1. Historical context. Past. Rocket Lab's origins are deeply rooted in the advancements of rocket propulsion technology. The Air Force Rocket Propulsion Laboratory (AFRL), established in the 1950s, played a crucial role in developing technologies for intercontinental ballistic missiles (ICBMs). The development of the LR-87 engine for the Titan ICBM marked a pivotal moment in U.S. aerospace history, leading to innovations like storable propellants that enhanced launch readiness and operational flexibility. In 2006, Rocket Lab was founded with the mission of revolutionizing access to space. The company quickly gained recognition for its Electron rocket, which became the second most frequently launched U.S. rocket. The Electron's success can be attributed to its innovative design, including the Rutherford engine, notable for being the first 3D printed electric pump-fed engine. 2. Current operations. Present. Rocket Lab has positioned itself as an end-to-end space solutions provider, offering reliable launch services, satellite components, and on-orbit management. The company has successfully completed numerous missions using the Electron rocket, deploying over 200 satellites for a diverse range of customers in commercial, civil, and defense sectors. Current initiatives at AFRL include the Integrated Powerhead Demo (IPD) and Upper Stage Engine Technology (UST), aimed at modernizing propulsion systems. The Hydrocarbon Boost Demo (HCB) and Rotating Detonation Rocket Engine (RDRE) programs represent significant advancements in engine technology, focusing on efficiency and reusability. Rocket Lab's operations are supported by several launch facilities, including Launch Complex 1 in New Zealand and Launch Complex 2 in Virginia, USA. The company has expanded its capabilities to include satellite design and manufacturing, space software, and a variety of spacecraft components, thus providing a comprehensive suite of services to its clients. 3. Future prospects. Looking ahead, Rocket Lab is actively developing the Neutron rocket, a next-generation launch vehicle designed for larger payloads and satellite constellations. The company also aims to streamline space access through its Affordable Responsive Modular Rocket (ARMR) initiative, which seeks to significantly reduce development costs and time. AFRL's Tactically Responsive Space Access (TRSA) initiative aims to enhance military space operations by enabling rapid launch capabilities akin to UAV operations. This initiative emphasizes the importance of partnerships with industry players to create robust technology bases for on-demand space access. 4. Key developments. Timeline. 1954 – Development of the XLR-87 engine begins at AFRL. 1957 – First engine delivered, Titan ICBM launches in 1959. 2006 – Rocket Lab founded, begins work on Electron rocket. 2017 – Electron's inaugural launch, becomes a leader in small satellite launches. 2021 – Announced Neutron rocket, aims to expand into larger payload capabilities. 2023 – Continued development of modular rocket technologies and partnerships for TRSA. 5. Common themes and differences. Both AFRL and Rocket Lab narratives highlight the importance of innovation and the role of public-private partnerships in advancing rocket technology. However, the emphasis varies. The AFRL source focuses more on military applications and historical developments, while Rocket Lab underscores commercial viability and a broader range of space solutions. Conclusion. Rocket Lab's evolution from its historical roots in military aerospace to becoming a prominent commercial launch provider illustrates the dynamic nature of space technology. With ambitious plans for future projects like the Neutron rocket and an emphasis on responsive space operations, Rocket Lab is poised to play a critical role in shaping the future of space exploration and utilization. This comprehensive summary encapsulates Rocket Lab's journey, reflecting on its past achievements, current capabilities, and future ambitions as a transformative force in the aerospace industry. Counterintuitive information in Rocket Lab's past, present, and future. 1. Shift from military to commercial focus. While Rocket Lab has deep roots in military aerospace, including its early history linked to ICBM development, its transformation into a commercial entity with a focus on small satellite launches is somewhat unexpected. It is counterintuitive that a company with such a strong military background would pivot to become a leading provider for the commercial space sector, especially given the high barriers of entry in the aerospace industry. 2. Rapid evolution of technology. The speed at which Rocket Lab has advanced its technology is surprising. From its inception in 2006 to becoming a key player in the launch market with the Electron rocket within just over a decade is not the norm in aerospace, which typically sees slow incremental advancements. This rapid development challenges the assumption that aerospace innovation must follow a lengthy and deliberate pace. 3. Public-private partnerships (PPPs) dominance. Many might expect that a military-focused entity like the AFRL would primarily operate in isolation or within government contracts. However, Rocket Lab's successful integration of public-private partnerships to leverage advanced technologies and expertise represents a shift from traditional government-only approaches. This model enhances innovation and speed to market, defying the expectation that military projects must remain within the confines of government. 4. 3D printing in rocket engines. The use of 3D printing for rocket engines, as exemplified by Rocket Lab's Rutherford engine, is surprising given the industry's historical reliance on traditional manufacturing methods that emphasize precision machining and assembly. The acceptance and successful implementation of 3D printing in a field where failure can have catastrophic consequences challenges preconceived notions about manufacturing reliability and safety in aerospace. 5. Modular rocket development. Rocket Lab's development of the Affordable Responsive Modular Rocket (ARMR) challenges the conventional belief that rocket designs must be large, complex, and unique for each mission. The idea of creating a modular rocket system that can be rapidly developed and deployed is a departure from traditional aerospace thinking, which often prioritizes singular purpose-built designs. 6. Focus on small satellites. The extent to which Rocket Lab has specialized in small satellite launches might seem counterintuitive given the increasing demand for larger payloads in space. However, the significant market for small satellites driven by advancements in technology and the proliferation of companies with various missions showcases a sector that is often overlooked but rapidly growing. 7. Tactical space access. The concept of tactically responsive space access (TRSA) suggests a military utility of space that is more akin to UAV operations than traditional missile launches. This contrasts with the conventional view that space operations are exclusively large-scale and pre-planned. The military's interest in rapid, on-demand space access blurs the lines between traditional aerospace operations and modern military strategies. 8. Emphasis on reusability. Rocket Lab's emphasis on reusability, particularly with their Electron rocket and future Neutron rocket, might seem counterintuitive in an industry historically dominated by single-use launch systems. This shift indicates a growing recognition of the need for sustainability and cost efficiency, which challenges the long-standing norm in the aerospace sector. 9. International operations. The global reach of Rocket Lab, including operations in New Zealand and the US, challenges the notion that successful aerospace companies must be based solely in traditional aerospace hubs like the US or Europe. Rocket Lab's international footprint reflects a more democratized approach to space access, opening the door for companies from diverse locations. 10. Public engagement and community focus. Rocket Lab's efforts to engage with local communities and promote educational initiatives in aerospace may seem secondary to their technical endeavors. However, their commitment to community outreach and education supports an understanding that the future of aerospace relies not just on technology but also on cultivating interest and talent in the field. This holistic approach contradicts the stereotype that aerospace companies focus solely on technological advancements. In conclusion, Rocket Lab's journey showcases several counterintuitive elements that challenge traditional perceptions of the aerospace industry. From its transition from military to commercial focus, rapid technological advancements, reliance on public-private partnerships, and innovative approaches to rocket design and launch strategies, Rocket Lab exemplifies a new era in space exploration that prioritizes flexibility, accessibility, and sustainability. Important content in the report on Rocket Lab, past, present, and future. While the comprehensive summary provides a well-rounded picture of Rocket Lab's evolution and ambitions, several crucial aspects are likely to be overlooked by the general audience. These include the intricate interplay between historical military research and contemporary commercial applications, the significance of emerging technologies like the rotating detonation rocket engine (RDRE), and the strategic implications of Rocket Lab's partnerships with the AFRL Air Force Research Laboratory and other entities. 1. Historical military roots and their impact on modern commercial aerospace. Many people might focus on Rocket Lab's current commercial successes, such as the Electron rocket and the upcoming Neutron rocket. However, the historical context reveals a deeper connection between military research and today's commercial aerospace sector. Rocket Lab's origins are intertwined with the AFRL, which has consistently contributed advanced propulsion technologies that have been adapted for commercial use. Why it's significant. Understanding this historical backdrop is crucial for grasping the technological evolution within Rocket Lab. The transition from military to commercial applications not only showcases the versatility of these technologies but also highlights how historical defense projects have laid the groundwork for modern aerospace innovations. The ability to leverage decades of military research accelerates the development timelines and enhances the reliability of commercial launch vehicles. This historical perspective helps illustrate the broader trend of dual-use technologies in aerospace, technologies initially developed for military purposes being repurposed for commercial applications, leading to advancements in efficiency and cost-effectiveness. 2. The rotating detonation rocket engine (RDRE). The RDRE program represents a significant leap in propulsion technology, utilizing detonation-based combustion instead of traditional deflagration. Many readers may overlook its potential implications for the future of rocketry. The RDRE has the capacity to dramatically reduce the size and weight of rocket engines while increasing thrust and efficiency, thereby allowing for greater payload capacities. Why it's significant. The RDRE technology could redefine propulsion systems in a way that fundamentally alters the economics of space access. By decreasing the mass of engines and increasing efficiency, the RDRE might enable more frequent and cost-effective launches, which is vital as the demand for satellite deployments and space exploration increases. Moreover, the successful integration of RDRE into Rocket Lab's platforms could position the company as a leader in next-generation propulsion technology, potentially outpacing competitors who rely on traditional engines. 3. Public-private partnerships (PPPs) and their strategic importance. The collaborative efforts between Rocket Lab and the AFRL are often mentioned, but the strategic importance of these partnerships is frequently understated. These PPPs provide Rocket Lab with access to advanced technologies, testing facilities, and expert knowledge that significantly enhance its capabilities. This collaboration is not just a business strategy, it is a vital component for maintaining competitiveness in an industry characterized by rapid technological advancements. Why it's significant. The significance of these partnerships extends beyond mere resource sharing. They represent a model for how private companies can effectively collaborate with government entities to drive innovation. As national security concerns continue to evolve, the relationship between defense and commercial aerospace sectors could become increasingly important. The advancements facilitated by these partnerships could lead to breakthroughs that benefit both military applications and commercial ventures, fostering a more integrated approach to space access and utilization. 4. Technological innovations and future prospects. While the development of the Neutron rocket is rightly highlighted, the report gives less emphasis to the specifics of other technological innovations that Rocket Lab is pursuing, such as the Affordable Responsive Modular Rocket ARMR initiative. This program aims to revolutionize the design and development process of rocket engines, drastically reducing costs and time. Why it's significant. The ARMR initiative has the potential to change the landscape of space launch services by making them more accessible to smaller players and startups that might not have the capital for traditional launch costs. By democratizing access to space, Rocket Lab could help stimulate innovation and new business models within the space economy. Additionally, if successful, ARMR could lead to a new generation of modular rocket systems capable of rapid reconfiguration for different missions, further enhancing mission flexibility and responsiveness. 5. Future market dynamics, the role of responsive space. The report touches upon the concept of responsive space but does not fully explore its implications. The push for tactically responsive space operations, akin to UAV deployments, could fundamentally change the way military and commercial entities approach satellite launches and on-orbit operations. Why it's significant. Responsive space capabilities could lead to a shift in how nations and private companies perceive and utilize space. The ability to launch on demand could be crucial in scenarios where rapid response is necessary, such as in national defense or disaster relief missions. This capability could also enable a new era of space exploration where timely launches can be aligned with scientific opportunities, thereby maximizing the impact of research missions. Rocket Lab's leadership in developing these responsive capabilities could position it as a pivotal player not just in commercial launches but also in strategic military and scientific operations. Conclusion. In summary, the report on Rocket Lab encapsulates a fascinating narrative of innovation and ambition in the aerospace sector. However, the nuances of its historical military roots, the transformative potential of new propulsion technologies like RDRE, the strategic importance of public-private partnerships, and the broader implications of responsive space operations are crucial elements that deserve greater attention. Understanding these aspects allows for a deeper appreciation of Rocket Lab's role in shaping the future of space exploration and commercial spaceflight, revealing how past developments inform present capabilities and future possibilities. Analysis of Rocket Lab, past, present, and future. 1. Historical context and technological innovations. Rocket Lab's historical roots provide a rich background for its evolution within the aerospace sector. Initially founded in 2006, Rocket Lab emerged from earlier military and defense technologies developed by the AFRL Air Force Research Laboratory. The evolution of propulsion technologies, such as the transition from traditional fuels to storable propellants, showcases Rocket Lab's commitment to innovation. This historical context not only highlights the technological advancements that set the foundation for Rocket Lab's current capabilities but also emphasizes the importance of public-private partnerships in fostering growth and development in aerospace technology. The company's development of the Electron rocket and the Rutherford engine exemplifies its pioneering spirit and the shift towards more efficient, commercially viable launch systems. 2. Current operations and market position. Rocket Lab has successfully positioned itself as a leader in the small satellite launch market with its Electron rocket, which is notable for being the second most frequently launched U.S. rocket. The company has established an end-to-end space solutions provision which includes satellite components and on-orbit management. Rocket Lab's operational capabilities extend beyond mere launch services, encompassing satellite design and manufacturing, which opens multiple revenue streams. The successful deployment of over 200 satellites underscores its reliability and market trust. The ongoing development of the Neutron rocket indicates a strategic pivot to accommodate larger payloads and expand its market reach. This operational versatility is vital in an increasingly competitive landscape where companies like SpaceX dominate the market. 3. Future prospects and strategic initiatives. Looking ahead, Rocket Lab's future initiatives, such as the development of the Neutron rocket and the Affordable Responsive Modular Rocket ARMR program, are critical to its growth potential. Neutron aims to serve larger payloads and satellite constellations, signaling Rocket Lab's intent to compete in a broader segment of the launch market. Moreover, the ARMR initiative seeks to drastically reduce development costs and timelines, which could make Rocket Lab a more attractive option for potential customers. The emphasis on rapid launch capabilities through the Tactically Responsive Space Access (TRSA) initiative reflects a proactive approach to meet the evolving demands of military and defense sectors, indicating a strategic alignment with government needs. As these initiatives materialize, they will be crucial in determining Rocket Lab's competitive stance in the future. 4. Collaborative ecosystem and the role of public-private partnerships. The collaborative ecosystem surrounding Rocket Lab is a key theme in both its historical and current operations. The partnership with the AFRL has enabled Rocket Lab to leverage advanced technologies and expertise that would otherwise be inaccessible. This relationship has facilitated the transition from military-focused technology to commercial applications, demonstrating the effectiveness of public-private partnerships in driving innovation. The continued emphasis on collaboration with various stakeholders, including government entities and other aerospace companies, will be crucial as Rocket Lab navigates the complexities of the aerospace industry. The establishment of the Gateway to Site initiative further illustrates Rocket Lab's commitment to enhancing industry partnerships and improving access to its technologies and facilities. Conclusion. In summary, Rocket Lab's journey from its historical origins to its current operations and future aspirations is characterized by significant technological advancements, strategic market positioning, and a robust collaborative framework. Analyzing these 4 key points: historical context, current operations, future prospects, and collaborative ecosystem, provides a comprehensive understanding of Rocket Lab's role in the aerospace industry and its potential to shape the future of space exploration and utilization. 1. Each case of SpaceX. Founded in 2002 by Elon Musk, SpaceX revolutionized the aerospace industry by focusing on the development of reusable rocket technology. Its Falcon 1 marked the first privately developed liquid-fueled rocket to reach orbit in 2008. SpaceX has since achieved numerous milestones, including the first private spacecraft to reach the International Space Station Dragon and the groundbreaking Falcon Heavy launch, which is currently the most powerful operational rocket in the world. SpaceX's emphasis on cost reduction and the development of the Starship vehicle for deep space exploration has positioned it as a leader in the commercial space sector. 2. A case of Blue Origin. Founded by Jeff Bezos in 2000, Blue Origin aims to make space travel more accessible and sustainable. The company developed the New Shepard suborbital rocket, which successfully completed its first crewed flight in July 2021. Blue Origin is also working on the New Glenn orbital launch vehicle designed to carry large payloads to orbit and the lunar lander Blue Moon, intended for NASA's Artemis program. Blue Origin's focus on reusability and its collaboration with NASA and other commercial partners illustrate its commitment to advancing space technology and exploration. 3. Case of United Launch Alliance (ULA), formed in 2006 as a joint venture between Boeing and Lockheed Martin. ULA provides reliable and cost-effective launch services for government and commercial customers. Its Atlas V and Delta IV rockets have been instrumental in deploying satellites and supporting national security missions. ULA is now transitioning to the Vulcan Centaur rocket, which emphasizes reusability and cost efficiency. By partnering with various governmental and commercial entities, ULA continues to play a pivotal role in the evolving landscape of space access and exploration. Future outlook: Rocket Lab. 1. Expansion into larger payloads. Rocket Lab is set to significantly broaden its capabilities with the development of the Neutron rocket. This next-generation launch vehicle is designed to handle larger payloads including satellite constellations and interplanetary missions. By 2025, Neutron is expected to play a pivotal role in deploying massive networks of satellites that will support global internet coverage, Earth observation, and various scientific endeavors. 2. Enhanced reusability and cost efficiency. As the aerospace industry increasingly shifts towards sustainability and cost efficiency, Rocket Lab's focus on reusability will be crucial. The company aims to implement reusable first stages for the Electron rocket building on its mid-air recovery attempts. This initiative will likely reduce launch costs and increase launch frequency, making space more accessible for a broader array of customers. 3. Integration of advanced propulsion technologies. Rocket Lab's collaboration with the AFRL on advanced propulsion technologies will likely yield significant breakthroughs in rocket engine design. The ongoing development of modular engines through the Affordable Responsive Modular Rocket ARMR initiative could lead to engines that are cheaper and faster to produce, enhancing Rocket Lab's competitive advantage in the market. 4. Responsive space operations. With the Tactically Responsive Space Access TRSA initiative, Rocket Lab aims to create a responsive launch capability akin to UAV operations. This could position the company as a leader in military and urgent commercial space operations, allowing for rapid deployment of satellites and other payloads in response to immediate needs. 5. Partnerships and collaborations. As Rocket Lab continues to forge public-private partnerships, it is likely to expand its technological prowess and operational reach. Collaborations with governmental and private entities will enhance its development capabilities, particularly in innovative propulsion systems and satellite technology, ultimately positioning Rocket Lab as a comprehensive space solutions provider. 6. Focus on space systems and on-orbit management. Rocket Lab is not just a launch service provider, it's evolving into a full-spectrum space systems company. By enhancing its offerings in spacecraft components and on-orbit management, Rocket Lab aims to capture a larger share of the satellite market. This will involve developing technologies for satellite operation, data collection, and communication, thereby solidifying its role in the burgeoning space economy. 7. Emphasis on global market expansion. Rocket Lab is likely to focus on expanding its global footprint. As the demand for satellite launches grows in emerging markets, Rocket Lab may establish additional launch sites and facilities worldwide. This strategic move will enable the company to cater to a diverse clientele and tap into new markets, increasing its revenue streams. 8. Sustainability initiatives. With growing concerns over climate change and the environmental impact of space launches, Rocket Lab is expected to pursue sustainable practices. This includes developing eco-friendly propellant options and reducing the carbon footprint of its operations, aligning with global sustainability goals and appealing to environmentally conscious clients. 9. Technological innovations. The future of Rocket Lab will be marked by continuous technological innovations. The development of the rotating detonation rocket engine (RDRE) could revolutionize propulsion systems, offering higher efficiency and reduced costs. Such advancements will not only enhance Rocket Lab's launch capabilities but also contribute to the evolution of space exploration technologies. 10. Dominance in the small satellite market. As the small satellite market continues to grow, Rocket Lab is poised to maintain its leadership position. With its proven track record of successful launches, the company will likely capitalize on the increasing demand for small satellite deployment, catering to commercial, civil, and defense sectors. Conclusion. Rocket Lab's future appears bright, driven by its innovative spirit and strategic initiatives. By focusing on larger payloads, reusability, advanced propulsion technologies, and global market expansion, Rocket Lab is set to redefine access to space in the coming years. As the company continues to evolve and adapt to the dynamic aerospace landscape, it is well positioned to play a significant role in shaping the future of space exploration and utilization.